the Earth's magnetic field is about to flip. This means the magnetic North Pole will become the South Pole, and vice versa. While such shifts, called geomagnetic reversals, have happened many times throughout Earth's history, this is the first time in recorded human history. Scientists are studying the potential impacts of this upcoming shift, which seems inevitable and may have already started. These reversals typically occur every 200,000 to 300,000 years, and the last one was about 780,000 years ago, making the next one overdue. If the magnetic North Pole jumps to the South Pole and vice versa, the Earth's magnetic field changes dramatically in the course of the jump. It even shows extreme weaknesses for a certain period of time. During this time, our civilization is exposed to an increased risk of solar storms. Normally, the magnetic field reliably intercepts the particle streams from the Sun, but when it weakens, more charged solar particles can penetrate into the deep layers of the Earth's atmosphere and possibly cause damage. If we then also experience a peak in solar activity, as is currently the case, it could become really dangerous. Experts warn that a gigantic solar storm could paralyze our entire modern civilization. The duration of a pole shift is estimated to be between 1,000 to 10,000 years. It sounds eerie and fascinating at the same time. A pole shift means a complete magnetic reversal of our planet, north becomes south and vice versa. We humans have never consciously experienced this process, and we do not know what a pole shift will be like. It may feel like nothing changes, or we may experience major disruptions and possibly massive failures of technical equipment. The magnetic field is not absolutely essential for us humans to live, or, let's put it this way, the effects of the Earth's magnetism on us humans have hardly been researched, if at all. Scientists assume that animals use the magnetic field for orientation, and as already mentioned, the field protects us from the solar particle streams. These currents wouldn't be a problem for the globe, even if they occur at longer intervals and in concentrated bursts. Again, it's our modern human culture that is at risk due to our dependence on technology. Animals and the planet itself can usually withstand such changes very well. A pole shift is probably not a sudden process, it may take place over 1,000 to 10,000 years. During this time, the magnetic field weakens and becomes more chaotic, with the poles repeatedly shaking or wandering erratically before realigning. Pole jumps occur as a result of changes in the flow patterns of the liquid metal in the outer core. This is where the magnetic field is generated by an effect that scientists call the geodynamo. Influenced by thermal convection, the rotation of the Earth, and possibly other factors from space, the polarity of this geodynamo changes, and the orientation of the poles changes with it. Current processes in the Earth's magnetic field are alarming. The Earth's magnetic field is currently changing in a remarkable way. Over the last 200 years, the magnetic field has lost about 10% of its strength. It is observed with concern that the magnetic field continues to lose strength, and the rate of this decrease seems to be increasing. For some time now, there has been a region with a severely weakened magnetic field over the South Atlantic. This anomaly is growing daily and, in the worst case, will spread to form a gigantic hole. In this region, satellites and electronic devices are already increasingly exposed to cosmic radiation, and nobody knows where this development will lead. In the north, strange changes have been observed since the 1990s. Since then, the magnetic North Pole has been moving faster and faster. From a few kilometers per year, the rate increased to around 50 to 60 kilometers per year. At the moment, the magnetic North Pole is approaching Siberia. This still sounds extremely northern to us, but there is a considerable distance between the original North Pole and its current position. Scientists distinguish between several poles. Our Earth has a North Pole which, measured along the Earth's axis, is almost invariable. Although our planet has experienced axial shifts in its history, these events are less frequent than magnetic reversals. Of course, our globe also has a purely geological North Pole at the top of the northern hemisphere. The magnetic North Pole is determined by the pure rotation of the Earth's magnetic field. Traditionally, all these poles deviate slightly from one another and do not lie synchronously at one point. The magnetic pole is the most active, and it wanders the most. The magnetic field does not envelop our Earth statically, it circulates and fluctuates. Some scientists are skeptical, are we really facing a pole shift, or is it all just fear-mongering? The last pole jump, about 780,000 years ago, was a long time ago. Considering that such events occur on average every 200,000 to 300,000 years, scientists suspect that such periods without a pole jump are just as normal as cycles of several 100,000 years. There have been demonstrably phases in the Earth's history in which no pole jump occurred for several million years. Researchers refer to such phases as supercrons, and we could be in the middle of one of these periods. During the Cretaceous supercron, the Earth's magnetic field remained stable for about 30 million years. We could currently be in a similar but shorter phase. The tremor of the North Pole would then be a normal fluctuation and not a sign of a complete leap. The reasons for an unusually long stability of the Earth's magnetic field could be geodynamo mechanisms. The outer core of the Earth could be in a particularly stable phase, whereby the flow patterns in the liquid iron are currently hardly disturbed. Some researchers convincingly argue that geomagnetic reversals are chaotic and difficult to predict. So long pauses are not unusual. They say that without further evidence, it's not possible to confidently predict a pole reversal for the next 10,000 years. During a pole shift, the Earth's magnetic field will definitely weaken, which could mean that the Earth is temporarily less protected from radiation from space. This could weaken nature and perhaps also our bodies in some ways. The exact effects of a sharp decline in the magnetic envelope of our planet have not been sufficiently researched. However, it's certain that technological systems such as satellites and communication networks would be disrupted by the radiation. In addition to disruptions to communication systems, we could experience power outages. It's possible that more animals will stray into areas where they do not belong. Whales beaching themselves on shores is just as likely as large flocks of birds getting lost. We can't predict how quickly animals will adapt to a magnetic pole shift, or if their internal navigation will adjust faster than ours. The impact on weather and climate is also highly debated. Essentially, we're unsure of the consequences if magnetic north and south reversed. However, a pole shift would definitely create significant problems for our technology-dependent world. Scientists are closely monitoring the situation to identify and assess potential dangers as early as possible.